This is the video for Unit 4, Lesson 5, Finding Holes in Rational Functions. The goal is going to be to basically still continue to graph a rational function, but identify where there might be what we call a hole in the function. So it's really tying together all the stuff we've done and also tying in some components of factoring. So a hole is in a rational function occurs when there's a common factor, and that's kind of the big key here. After we factor, we're going to find there's a common factor that appears in the numerator and the denominator. So what happens is there's an x value that basically causes the numerator and the denominator to be 0 at the same time. So that's where we get a hole that occurs in there. So that's basically going to be something we identify in our domain. But as opposed to being an asymptote, we're going to be talking about a hole. So it's a little bit different than an asymptote. It looks like just that, a hole. So let's look at this first example so we can kind of see what that means. So we're going to approach it the same way. So I look at my top part of my function. So it's f of x equals x plus 2 over x squared minus 4. The top part, nothing really changes. The bottom part, though, I could actually factor that out. That's a difference of two perfect squares. So if I go ahead and factor that out, I get x plus 2. And the bottom is actually x plus 2, x minus 2. It's a difference of two perfect squares, just like we saw in the last unit. Something we're going to notice here, first of all, we always want to identify our domain, but we're going to see something interesting happens. We have the same factor occur at the top, and it also occurs at the bottom. So our domain, we're going to do the same way. If I take set the bottom part equal to 0, I get my domain is I'm not allowed to have negative 2 in my answer, and I'm not allowed to have positive 2, right? The thing that happens is when we put negative 2 back into the function, we're actually going to get, like if I was to do f of negative 2, I would actually get 0 over 0, right? Which is kind of a weird answer to get. So what that means is we're going to get a hole in our graph because the same factors appearing on top and bottom, and I would get 0 over 0. So we have our domain. What we then actually identified is that we actually do have a hole. So what happens is just like we have if I have like 5 over 5 reduces to 1, or 3x over 3x reduces to 1. If I divide a factor by itself, it actually comes out to just be a 1. So on the top now I'm left with a 1. On the bottom I'm left with x minus 2. So what we just did was just simplify this out. But I'm going to keep in mind that I have a hole at that factor of x plus 2, which is essentially at negative 2. All right, so now the rest of this, I'm going to use my new simplified function, but I'm going to keep in mind that I actually do have a hole in this graph. It's actually, again, at negative 2, and a value I'm going to find out in a moment. Okay, so now I'm going to answer the rest of my questions using this that I have highlighted in green, the 1 over x minus 2, and just keeping in mind that I do have a hole that I have to address later. So now if I go ahead and do my same stuff that we usually do, we actually have that I have 1 over x, so my horizontal asymptote is y equals 0. I do have a vertical asymptote, but again, it doesn't match exactly the domain. It's just going to be the 2, right? Because I'm going off this new function that's simplified. So that minus 2 isn't, again, an asymptote. Since it canceled with the top, it's going to create a hole. The x-intercept, I'm going to do the same thing I did before. If I set the top equal to 0, it wouldn't make any sense. So there's no x-intercept. And then the y-intercept is if I evaluate f of 0. And again, I'm going to use my new function, or the simplified. So 0 minus 2 would be negative 1/2. So y-intercept of 0, negative 1/2. All right. Now we came back to where we saw that we have this hole that we need to address. So what we do then is we take this negative 2, And we want to think of where that hole would actually be. So I'm going to go ahead and put -2 into this simplified function. So otherwise, if I put it into the other one, it's just going to give me 0 over 0, which doesn't help anything. So -2 minus 2, that will be a -4. So I get -1/4. And so what that means is at -2, -1/4, there's not an asymptote, but there's going to be a little gap in our graph. So we're going to go ahead now and graph everything else. So we have a horizontal asymptote at 0, so y equals 0. We have a vertical asymptote at 2. Okay, we're going to plot all of our intercepts. So our intercept, we don't have an x-intercept, but we have a y-intercept at 0, -1/2, which is like right around here. And then finally, we're going to end up having a hole. I'm going to do the hole even in a slightly different color. At -2, -1/4, I'm going to draw like almost like an exaggerated hole there. So we actually do have the part of the graph is living in that lower left part. I'm going to do my best to kind of draw a sketch here. But notice that we're going to make sure we leave kind of like an exaggerated hole. So if I was to look at that piece, it's just a little gap in the graph. So I'm in that lower left, so I know that to be symmetrical, I'm going to graph the other piece of the graph and just do my best to draw a sketch in the upper right. And that would be my graph. So it looks just like what we did. The only difference was our domain didn't match exactly with our vertical asymptote. So notice our domain appeared as a asymptote and as a hole because the same factor was on the top and the bottom. We'll have you try the u-try, but I'm going to do the same thing with this example too, right? So we're going to approach everything the same way. We're just going to know something different happens after we factor. So for this next one, we're going to see that when we factor, it's a trinomial. So I'm going to write x minus 9, x plus 2, or x minus 2. On the bottom, I'm going to write x plus 6, x minus 2. I'm going to do my domain like I normally would. All right, I see I can't, if I set this bottom to 0, I'm not going to have a -6, and I can't have a +2. So everything else looks pretty much the same now. What you're going to notice again is we have a factor that matches on the top and the bottom, which didn't appear in any of the other previous lessons. So that's kind of the one thing that's new, is we get the same thing on the top and the bottom. So what that means is at +2, I'm going to have a hole. So I'm going to cross it out. I'm going to rewrite my function now as simplified, knowing though, again, that I have a hole that's going to appear at +2. So now we're going to go ahead and answer the rest of our questions using this new simplified function. But again, we have to address that hole at the very end. So our horizontal asymptote, if I take a ratio of the leading, so x over x, if I simplify that, I get a 1. So my horizontal asymptote's at 1. My vertical asymptote, if I set that bottom, again, that's that -6. My x-intercept, I'm going to set the top equal to 0. And I get at 9, 0. And then our y-intercept, we're going to go ahead and we put 0 in for x. So we're going to get -9 over 6 or -3/2. So 0, -3/2. For the hole, we're going to go ahead and we take our function, and I'm going to evaluate what do we get when it is 2. And again, I'm using the simplified one. Otherwise, I'll get a 0 over 0. So 2 minus 9 over 2 plus 6 is -7 over 8. And then we're going to have a whole at negative 7 over 8, which is a little bit less than negative 1. All right, so about a little less than 2 negative 1. And now we're going to go ahead and do the same graphing that we've been doing. So our horizontal asymptote is at 1. Our vertical asymptote is at negative 6. All right, we're going to go ahead and graph our x-intercept at 9, 0. So 9, 0 is like right about there. We're going to go ahead and also graph our y-intercept at negative 1.5, 0. And then finally, we have a whole that's at 2 and negative 7/8. So 2 and negative 7/8 is like right around there. Kind of exaggerate it. And then we're going to do our best to draw a sketch. All right, so if I'm graphing in the lower right, I know my other piece is going to be in the upper left. And that would be our final answer. If you have any questions, you can ask them in class, sign up for T-Bolt time, or go to the center.